Hello students, welcome to the correction of Cyclic 1 paper, grade 10 physics. The paper was for 30 marks. This is your question paper. The question number 1, as we can see here, is define moment of force and state its units. The obvious answer for this is moment of force is basically the turning effect of force acting on a body about an axis is called moment of force. Important word over here is about an axis. Next question. State its units. The answer for this is Newton meter. N has to be capital, M has to be small if you write in short. If you write the entire answer, as in if you write the entire unit, both N and M from the words Newton meter have to be small. If both your parts or both your answers are correct, please award yourself 2 marks. We now go to the next question. Second question says factors on which moment of force about a point depends. The two factors on which the moment of force depends are the magnitude of the force applied or the quantity of force applied. Both the words are absolutely fine. The second factor is the perpendicular distance of line of action of force from the axis of rotation. This word perpendicular is a very important word, so it has to be there in your answer. Also, mention the distance between the two things that we're talking about. That is, you need to mention distance between the line of action, or you can also say point of application of force to the axis of rotation. So from and to has to be clearly mentioned. If you have mentioned both the points with all the required words very correctly, then please give yourself a 2 mark. If in the second point you have failed or forgotten to mention the word perpendicular or action, line of action or point of application of force or axis of rotation, then please do not give yourself a mark for the second part. You can still give yourself 1 mark if you have mentioned magnitude of force or the quantity of force as the first point. I hope I am very clear. We go now to the third question. The third question was again a derivation between the moment of couple, force, and couple arm. It's a very short derivation as we see it. Moment of force formula is F into the perpendicular distance. Moment of force at the B end is F into the perpendicular distance from the point of application of force to the axis of rotation. Total moment of force or total moment of couple will be F into this distance and F into this distance, so which is F into OB plus F into OA. F is taken as common. We have OA plus OB, which is the entire length AB from one point of application of force to the other point of application of force of the rod in the discussion. And therefore, we call that as a couple arm. So the relation is very simple. Moment of couple is equal to force into couple arm. If you mentioned the entire derivation as mentioned here on the answer paper, then please award yourself with 2 marks. Do you need to draw the diagram? I would suggest you to always draw a diagram for such a question. Coming to the fourth question here, the fourth question simply is a simple numerical, which has given us the questions of comparison of torques by the two forces. So to calculate the torque, I'm sure we are all aware, we will have to find the force and the perpendicular distance from the point of application of force to the axis of rotation. Now, interestingly, in this sum, F2 is the force, then point O becomes your axis of rotation, which simply tells me that F2 into 0.2, which is half of the diameter, will be the torque in the first case, that is for F2, and for F1, the torque will be value of F1 into the entire diameter. Why is that so? Because for the force F1, the axis of rotation will be point x. I repeat, for the force F1, the axis of rotation is point x, and therefore the perpendicular distance is equal to the diameter. So let us see the answer. We say torque F1, it will be the force which is 10 into the entire length of the diameter as discussed. So 10 into zero point 0.4 will give us 4 Newton meters, and torque produced by force F2, that is moment of force produced by force F2, will be 10, that is the value of force, into the radius, which is half of the diameter, which is 0.2. The answer is 2 Newton meters. Need not mention if both your answers and these values are correct. Please give yourselves 2 marks, or else depending upon your answers you can give yourself a 1 or a 0. Also moving ahead to the last question from the main question 1. State the position of center of gravity for a rod and a hollow cone. The answer is pretty straightforward. For a rod, it is the midpoint of the rod. It is the center of the rod is also absolutely acceptable. For a hollow cone, the center of gravity is at a height h by 3 from the base on its axis. So h by 3 has to be h by 3. From the base has to be mentioned. That's absolutely compulsory, right? On its axis is also important. So if you've written both of them exactly as it is required, then please give yourself 2 marks. If in the second part you haven't mentioned h by 3, or if you haven't mentioned from the base or on its axis, please do not give 1 mark for the second part. You can still give yourself 1 mark based on your answer in the first part. So that ends the question number 1. Now going to the question number 2. The first question in the question number 2 is a small derivation between the relation of mechanical advantage, velocity ratio, and efficiency. The answer goes like this. If you say a machine has overcome a load L by applying an effort E in time t, if the displacement is dE and the displacement of load is dL, then the work input, my dear students, work input will be the effort. Input refers to effort into the displacement of effort, so that is E into dE. Work output, so when it's output, it's on the load, hence work output will be load into displacement of load, which is L into dL. Efficiency, as we already know, is work output upon work input. Therefore, we get efficiency is equal to L into dL upon E into dE, taking the values from the top and substituting here. Once we get that part, then we can say L upon E is mechanical advantage. As we all know, L upon E is mechanical advantage, so it is replaced by MA, and dL upon dE is 1 upon velocity ratio. dL upon dE is 1 upon velocity ratio, and therefore the relation that we are looking at, the relation that has to be mentioned in your answer paper is efficiency is equal to mechanical advantage into 1 upon VR, or MA upon VR is equal to efficiency. If you've mentioned all of it just the way it is mentioned over here, you can please give yourselves 2 marks. Else, please do not award yourself just for the sake of it. It is absolutely imperative, compulsory, and necessary that you please honestly mark yourselves so that you get a clear picture of your preparation. Any lies or any dishonesty here will only hurt you in your scores and will bring a lot of disappointment later. It is better to take the disappointment on your chin right now and work on it rather than waiting for it to come to us later on. Coming to the second question in the question paper, second question of the main question number 2, it simply says give 2 differences between a single fixed pulley and a single movable pulley. The answer has to be exactly as mentioned over here. You can mention 2 out of the 3 differences. It is absolutely fine. That is fair. However, please remember that those points have to be contrasting, which simply says if here I mention about the fixed rigid point and here if it's mentioned about the non-fixed rigid point, that is how it should be. You cannot have the first point from here and the second point from here placed against each other. So the 2 points have to be distinguishing points and therefore they have to be contrasting points. So a set of 2 correct contrasting points will award you 2 marks. So based on what you've written from the answer paper, you can compare yourself and please award yourself marks accordingly. Coming to question number C of the main question number 2. We know that the load arm is 1.5 meters, the entire length of the crowbar, minus 1 meters, which is 0.5 meters. Effort arm is the distance from the support, the sharp edge, to our hand, which is 1 meter as given in the question. We know mechanical advantage formula is effort arm upon load arm. Effort arm is 1, load arm is 0.5, so 1 upon 0.5 gives you 2. So mechanical advantage is 2. Then we need to find the effort. To find the effort, we can use the formula load upon mechanical advantage. This is derived from the formula mechanical advantage is equal to load upon effort. Now substituting the value of load as 75 kgf as given in the question and mechanical advantage 2 as obtained over here, the answer comes out to be 37.5 kgf. So the effort is 37.5 kgf. The next part of the question is explain or state the type of lever. Now, since the fulcrum is between the load and the effort, this is a class 1 lever. If you've answered all these questions correctly, you can give yourselves 2 marks. Coming to the fourth question, question number D of the main question second. The first question is since since the load lies between the fulcrum and the point B. So if you see over here, the load is between the fulcrum and the point B. Therefore, this has to be a class 2 lever. Next part of the question is they ask us to find the mechanical advantage. Next part of the question is finding mechanical advantage. Given that FA is equal to 80 centimeters and AB is equal to 20 centimeters. Now, so mechanical advantage is the effort arm upon load arm, which is of course 80 upon 100 upon 80. That works out to be 1.25. It is 100 upon 80, so that is 1.25. That is the mechanical advantage of the question number D of main question number 2. Now coming to the question number E of main question number 2, we need to calculate the efficiency. We need to calculate what is the maximum load he can raise given the efficiency. So here we know efficiency is equal to mechanical advantage upon velocity ratio. Efficiency is given in terms of percentage. So write 60 upon 100. ये 100 कैसे आया? Because it's given 60%. So 60 upon 100. Velocity ratio given to us is 3. So we need to find the mechanical advantage using this formula, which works out to be 1.8. We also know mechanical advantage formula is load upon effort. Effort given to us is 200. So therefore the load works out to be 200 into 1.8, which is 360 kgf. So therefore we say the maximum load that can be raised by using this arrangement is 360 kgf. If this is the method that you followed and if you got the right answer, please award yourself 2 marks. Coming to the main question number 3. The first question of this main question number 3 is stating the applications of class 1, class 2 and class 3 levers. Answer for this goes as follows. The class 1 lever can be used as a speed multiplier, it can be used as a force multiplier, or it can also be used as a device that is used to change the direction. Class 2 lever, whereas is always used as a force multiplier, and a class 3 lever will always be used as a speed multiplier. If you've written all the answers, all three answers correctly, please award yourself with 3 marks. However, if you've missed off any out of these three functions in the class 1 lever, you can straight away deduct 1 mark and give yourselves 2 marks for these two answers. Alright, now coming to the B question of main question number 3, that is distinguish between ideal machine and practical machine. There are these 2 points given or mentioned over here. You will have to add one more point of your choice to this distinguish, depending upon the number of points that you've written and the correct contrast of those points. Please award yourself 1 mark for one pair of correct points. Going to the last question, the C part, the question number 3 of the main question number 3, the question goes as follows. Uniform circular motion is an accelerated motion. Explain the following. Also, name 2 forces involved in circular motion with the correct directions. Talking about the first part of the question, we say when a particle moves with uniform circular motion, the speed of the particle remains uniform, but as discussed, the direction of motion changes at each point on the path. Hence, the motion is said to be accelerated. I repeat, since the direction is changing, hence we say the motion is accelerated. If you've written this as your answer in the initial part, please award yourself with 2 full marks. Coming to the next part of the question, the 2 forces are centripetal, which is directed towards the center, and centrifugal, which is directed away from the center for a body which is in uniform motion. If you mentioned both the forces and with their correct directions and correct spellings, then please give yourselves 2 marks for the second part of this answer. That completes the answer statement